Okay, so one of the things that we're going to be talking about is the AP test. So one of the things that we're going to learn is this symbol that we have going on here. So first thing you need to know is this symbol right here is called a definite integral. It's called a definite integral because it has numbers on this symbol as the integration symbol. We have a and b. We can also call this the accumulator function. So we're going to be, because we're adding up those rectangles, so we're going to be looking at what this is. So a and b are going to be our bounds, our end bounds, the starting and the ending. F of x is the function that we're dealing with, and dx is the the variable we're going to be taking things with respect to. So write an expression that represents the area of the shaded figure above. So we have our integral, we need our bounds. So we have our lowest one is 2, our upper one is x. It is going to be of the function h of x, and we are going to be doing it with respect to x because x is inside of that value h. It's that function f of x. Okay, so we're going to be approximating and kind of interpreting what's going on in these values. So a large department store opens at 9 a.m. and closes at 9 p.m. The rate that the people enter the store in people per hour is modeled by the function p prime, where p is the number of hours since 9 a.m. The table above contains values of p prime at selected times t. Use the data in the table to answer the following. So use a left Riemann sum with 3 sub-intervals to approximate the area between p prime of t and the t-axis from 0 to 5. Include units of measure. What does the value represent? So one of the things that I know is that I need to find the left Riemann sum with 3 sub-intervals. I also know that I'm starting at 0 and ending at 5. So we are given a table here. So I'm going from 0 to 5. And I need to cut this into 3 pieces. Now our pieces don't necessarily need to be equal because we are looking at a table. So I can't just do 0 to 5 and divide it out. So if I look here, I'm going to be looking at between 0 and 2. I'm going to be looking at an interval between 2 and 4 and an interval between 4 and 5. This gives me my 3 sub-intervals. So those are the intervals we're going to be using. So the distance between our x values, 0 and 2, is 2. So that is the base of our rectangle. Now we need to think about what is the leftmost function. So the leftmost number between 0 and 2 is going to be 0, which means our y value, our height, is going to be 11. We are going to add to it the distance between our two x values for the next piece. So the distance between 2 and 4 is 2, and the leftmost number between 2 and 4 is 2, so I'm going to use 30 as my height. Our last one, the distance between 4 and 5 is 1. The leftmost number between 4 and 5 is 4, so we're going to use that y value of 54. One thing to know is that when we're doing these problems, even if it's calculator active, if we can write out those what we're multiplying together, we want to. They want to see what we multiplied together to see if we're actually doing a Riemann sum instead of something else. So we have 2 times 11 plus 2 times 30 plus 1 times 54. So you have 54 plus 60 plus 22. That happens to equal 136. So another thing that we want to think about is what is going on here? Like, what is this talking about? So these are talking about the rate that people enter the store in people per hour. So when we are doing this, we're going to take away that amount of time. So the amount of people per hour that were entering the store was represented by those rates, and now we have multiplied those hours out to them to create the number of people. So between the hours of t equals 0 and t equals 5, we had 136 people enter the store. So 5 hours after the store opened, 136 people entered the store. we could figure out if we opened at 9 a.m., then at 2 p.m., so between 9 a.m. and 2 p.m., the store had 136 people enter, but we also don't have to. We can just say 5 hours after the store opened. Okay. Use a right Riemann sum with 4 subintervals to approximate the area between p prime of t and the t-axis. Use t equals 4 to t equals 12. And use correct units. Interpret your answer in context. So we want 4 subintervals this time. We want right Riemann sums. And we want between 4 and 12. So we're starting at 4 this time. We're going to 12, and we want to cover this area here. So we have 1, 2, 3, 4. So these are the subintervals we're going to use. So we have right Riemann sums. The first one that we're going to look at is the distance between 4 and 5. The distance xy's between 4 and 5 is 1. When we're looking at what is more to the right, 5 is to the right a bigger number than 4. So we're going to use 26 as our y value. Our next piece, we have the distance between 5 and 6. 6 is to the right of 5. So we have our height of 21. The distance between 6 and 9 is 3. 9 is to the right of 6, so 44 is our height. And then our last one, distance between 9 and 12 is 3. And the amount of people that entered on the right side is 0. We're going to go ahead and combine this. We have 26 plus 21 plus 120 plus another 12. So 132 plus 0. This ends up getting us 179. And we're talking about people that have entered. So when the store was open between 1 p.m. and 9 p.m., the number of people entering the store is 179 people. Okay, so approximate the value of the integral from 0 to 12 of p prime of t using a midpoint Riemann sum of 3 subintervals as indicated in the table above. So we are using midpoint Riemann sums, and we are going to be using 3 subintervals. So we have our midpoint Riemann sums, 3 subintervals. One thing that we want to make clear is that this is approximating this integral, the integral from 0 to 12 of p prime of t dt. So we're going to use this midpoint to approximate this interval, so we want to know what m sub 3 is. So when we talk about midpoints, we want to look at what values we would be dealing with. So this time we're going between 0 and 12. And we want to break this up into our 3 intervals. So if I'm looking here, we have 1, 2, 3, 4, 5, 6 boxes between our 2 things. So we want to kind of deal with 2 boxes, and that makes that cutoff. So we want to deal with 0 to 4, we want to deal with 4 to 6, and we want to deal with 6 to 9. This makes it really easy for us because if I want to deal with a midpoint, our midpoint is going to be that value in between our n values. So our total base is going to be the distance between like 0 and 4, but the y value we're going to be looking at is going to be based off of the number in the middle. So our first piece, that distance between 0 and 4, is 4. And we're going to be multiplying it by the y value of 2. Well, the y value at t equals 2 is 30. We're going to add that to our distance between 4 and 6, which is 2. But we're going to be looking at 5 for our y value. Our y value would be 26. Plus, and then our last one, that distance between 6 and 12 is 6. And our y value at 9, which is that midpoint between 6 and 12, is 44. If I were to combine all of these things, that we're going to get 436 specifically people. So in context, when the store was open, there were 436 people who entered the store. So while the store was open between 9 a.m. and 9 p.m., 436 people entered the store.